I welcome you specially to the Supernovas TV. Okay, and today's class will be looking at motion in physics. What is motion? Okay, what is motion? Motion, we can simply say motion is the change in position of an object. Okay, is a change in position. Once an object changes its position, okay, with respect to time, that's motion. It can be by virtue of an applied force, okay? Applied force, okay, moving this object. So let's say we have an object here, something like this, static here, okay? And there is a force coming to this direction, okay? It pushes this object to this direction, okay? The object, okay, experiences what? Motion and moves. Okay, now we have types of motion in physics. We have types of motion. Let me just wrap this up, so I'll write that above for us to see. Okay, change in position of an object. Okay, then what are some of motion types of motion? Okay, we say we have one, we have translational motion. This type of motion is involved when an object changes its position from one point A, towards point B, point A to point B, okay, along a straight line. That is translational motion. From one point to another point, when the object changes its position by virtue of applied force. So the next one we have, okay, we have random motion. Random motion is like a zigzag motion. Okay, zigzag, any direction. Okay, it's a motion that can follow any direction. It's like a zigzag, okay, motion. You can say example motion of smoke particles. Motion of smoke particles. I hope you're following. That's a random motion. Okay, the other two types of motion, okay, we have oscillatory or vibratory motion, and we also have rotational motion. Let me rub this off again so that I will use illustration to show that. Okay, we're looking at types of motion, and then the third one we say is vibratory or oscillatory motion. Okay, this is like the to and fro movements, okay, of an object. It's moving to and fro, like the strings of a guitar, okay, the pendulum bulb, okay, that flows, that's okay, let's say from here, okay, we have something like this, okay, and then the motion goes like this. The center is from here to here, okay. So we have the motion, okay, to and fro, okay, that is oscillatory motion. We also have vibratory, still under this to and fro movement, okay, vibration of the skin of a drum, okay, we have that under vibratory or oscillatory motion. Okay, then we have the other one, okay, we have the other one, which is what? Rotational motion. We have rotational motion. Rotational motion. We can also see is circular motion. Okay, we can also see this type of motion move in circles. Motion in circles. Okay, about a fixed point. For example, now we have the blades of a fan. We have a fixed point here, and we have this. Okay, we have this, Okay, okay, when it moves like this is a fixed point. Okay, this is a fixed point. Motion in circles about a fixed point. That this is the blades, these are the blades of a fan now. Okay, moving in circles. Okay, now there is another form of motion which is relative motion. Before we go to other terminologies under motion, this motion part one. Okay, we're just going through the types of motion. Okay, we'll also look at what causes motion. Okay, now we're going into relative motion, and after that we'll go to speed, we'll go to velocity. Okay, please, if you're just coming across our video, kindly subscribe to the channel Supernovas TV. Okay, and so you see more and more of our videos. Okay, now we're looking at relative motion. Okay, relative motion is like the motion, okay, of A. You look at motion between two objects, A and B. Okay, let's say you're sitting in a car here, A, and outside the car you're seeing trees. Okay, now it will appear as if the car is static, if the car is moving while the trees are moving. Okay, meanwhile, the trees are not actually moving. This is what is moving. Okay, but since we are defining relative motion as the motion um, A, of a body A with reference from B, okay, reference from what, from B, so it's a relative motion. Okay, losing A as the definition of the motion of A, of sorry, using B as the definition of motion of what, of A. Okay, that's relative motion between two, okay, parts, between two parts. All right, now let's go to speed. Okay, let's go to speed, and then we'll move further to what, velocity. I hope you're following, please. Okay, speed. We say that motion is when an object changes what, position, right? Okay, so now speed is still unchanged in position, but when there is a time frame of that change in position, we say that object, okay, is having a value, okay, known as speed. Okay, so speed is the rate of change of distance. You can also say speed is equal to distance over what? Time. Speed is also equal to distance over time. Take note that since distance is in meter and time is in seconds, so the unit for speed is meter per second. Please take note of that, meter per second. We can also have speed as kilometer per hour. Depends, because kilometer is also another unit for distance and hour is another unit for time. Okay, now also take note that this distance does not show direction. Okay, so distance here is without direction, being a scalar quantity, take note. Meanwhile, speed, okay, since speed is the distance covered per time taken, so speed is also a scalar quantity, okay, with distance and time too. So they're all scalar quantities. No direction is given, it's just showing us the speed in kilometer per hour or meter per second, okay, covered, or the distance covered, okay, by that body in that certain time or in that time taken. So let's try to solve one question under speed, just to make sure we understand. Okay, I'll pick one question from pick one question. Okay, now the question says a car travels at an average speed and an average speed of 100 kilometers per hour. Okay, says what distance does it cover in 5 minutes? This question is asking us to find the distance this car will cover in 5 minutes. Remember, we said speed is equal to distance over what? Over time. Okay. Now, what were we given here? We're given speed. Our speed was given as 100 kilometer per hour, and then time. Okay, we are going to be converting this 5 minutes to hours since our speed is in kilometer per hour. Okay, so that our distance will also be in kilometers. Take note, in physics we have to work with units, identical, the units have to agree. Okay, so we say t is what? 5 minutes. Now converting 5 minutes, if you are to express this in hour, okay, this is the same thing as having it as 5 over 60. Okay, 5 over 60 minutes, because 60 minutes will equal 1 hour. So that's the same thing as 1 over 12. We can use 1 over 12 to simplify further. We are asked to find distance. Okay, just so we can see what we are doing very clearly, I'll rub this off. And our distance, if speed is equal to this, okay, it means distance is equal to what? Speed times time. Speed times time. Our speed was given as 100 kilometers per hour times 1 over 12. That's what we did when we divided. So this becomes 100 over 12. If we divide this, it should give us 8 points. Okay, that we have 96. Okay, remainder 4. Okay, add 0, so that will be 3. Okay, can 3 so approximately we have 8.3 kilometers. That is this distance covered by this car. I hope you're following. Okay, now let's go back to, apart from distance, now an object can change its direction or it can change its position in a given direction. If that is done, if the direction is given, then we say the object has undergone what? Displacement. For example, an object moved 3 kilometers due east. Due east here shows us the direction of that object in motion. Okay, so displacement here, we can say displacement is a vector quantity because it gives us the magnitude, okay, which is this, and it also gives us the direction, okay, which is this. Now that takes us to velocity. Velocity, on the other hand, is the rate of change of displacement with time. So velocity is what? Displacement over what? Over time taken. Okay, displacement over time taken. It has the same unit as speed, okay, because it's still displacement is still time, the distance traveled, but displacement now is having direction. Okay, so velocity and displacement are both vector quantities having the same meters per second as the unit. Okay, so we can solve questions, okay, on velocity just as we can solve using speed. It's just the difference here is displacement, we can be given direction, and our final answer will also express in meters per second. Okay, in the next class, we are going into acceleration. Okay, we'll look at the velocity time graph. Take note, we are still on motion part one. Look at the velocity time graph. Okay, how to get out of that distance, acceleration, deceleration from the velocity time graph, and all that. Before we go to motion part two, where we'll be looking at formulas of motion. Okay, first, second, third, all the formulas of motion, and we use them to solve questions. I hope you enjoyed the class today. I hope look forward to see you in the next class. Thank you. Bye.